Let's look at a question from last year's Euclid exam, where we're looking for positive integers a, b, c, and d, with a less than b less than c less than d, satisfying both of these equations. Typically, we would try a substitution or elimination technique to solve a system of equations. It doesn't appear that there's an opportunity for elimination here, given that none of the variables seem to be matching. So I'm isolating a in the second equation, subtracting b, c, and d from both sides. Now I'm substituting a into equation 1 to see what happens. So we have 296 minus b minus c minus d times c, plus 296 minus b minus c minus d times d, plus bc plus bd equaling 2023. And you can see this is already looking quite complex as I multiply the c into the brackets. Minus cd. And it doesn't appear right away like we're making a lot of headway. And although in this method there are two of our variables that end up getting canceled out, we're still left with two variables to work with and a rather complex equation, and it may not be obvious where to go from here. So maybe this method of substitution also isn't the greatest idea. Let's try looking at equation 1 again and seeing if we can factor it. It looks like we could factor by grouping since we have 4 terms, and the terms seem to be already lined up in nice groups for us. So I'm going to factor a as a GCF out of the first 2 terms, leaving us with c plus d, and factor a greatest common factor of b from the second 2 terms, leaving us with c plus d again. And this gives us 2 factors of a plus b and c plus d. Now it's important to note here that since a, b, c, and d are all positive integers, that means that a plus b is a positive integer and c plus d is a positive integer. So we're looking for 2 positive integers that have a product of 2023. Well, what could those be? The obvious pair of integers is 1 and 2023. We have another option of 7 times 289, and we have 17 times 119. All of these give us a product of 2023. But which of these are valid solutions? Let's take a look at our second equation that shows our values of a plus b and c plus d must also have a sum of 296. So looking at our 3 possibilities, which of these pairs has a sum of 296? Only that second possibility does. 7 plus 289 is equal to 296. So that means we have a plus b must equal 7, and c plus d must equal 289. We can't have those reversed because since a is less than b is less than c is less than d, that means a plus b must be less than c plus d. Now we should determine what values are possible for a and b. Well, there's only a few. If a equals 1, then b would have to equal 6. If a is equal to 2, then b equals 5. And if a equals 3, b would equal 4. Could we go any further with this? If we did, with a equaling 4 and b equaling 3, then our inequality of A less than B would no longer be true. So these are the three cases that would work for A and B. Let's analyze case 1. If these are the A and B values, what could C and D be? Well, let's make a chart to track this. The lowest possible value of C is 7 because it must be greater than 6. That leaves us with a D value of 282 since they need to add up to 289. Similarly, we could have 8 and 281, and we could continue increasing the values of C while decreasing the values of D, all the way to what is the highest value of C that we could use? Well, we could use 144 for C and 145 for D. Again, any further, and our D value would then be less than C, which is not possible. How many pairs of numbers is this for C and D? Well, a subtraction 144 minus 6 would give us 138 pairs of numbers C and D that could go along with A and B being 1 and 6. Now, this is one of our three cases. We also have case 2, where A equals 3, A equals 2, and B equals 5. How many such numbers for C and D could complete our quadruple? I'll leave that to you, as well as case 3, for A equaling 3 and B equaling 4. Again, how many values of C and D would be possible? Once we have those three cases, we've already talked about how these are the only three cases that are possible. Then we could come up with a total number of quadruples, A, B, C, and D, which satisfy our equations from the question. Good luck solving the rest of this question.